Hello everybody, welcome to 1.6. I hope you found the formulas helpful to get you started going on some of these problems. This type of stuff is going to be helpful in calculus because you're going to be wanting to come up with equations based on the word problem, and so just be patient with yourself as you're going through these. The more you do, the better you're going to get. Alright, so for number 1, we have let P be a point xy on the graph of y equals x squared minus 8. And what we're going to want to do is express the distance d from P to the origin O as a function of x. Once we have that function, we're going to want to know what is d if x is 0 and what is d if x is 1. We'll then sketch that graph in Desmos, and we'll look at it for x greater than or equal to 0, and then we can use the graph to determine what value of x is d the smallest. So when we're looking at this problem, I'm seeing that there's the distance, so I'm probably going to be using the distance formula, but I think what would help me is just to sketch the graph y equals x squared minus 8. Let me put this line up here, and so the vertex is at 0, negative 8, and that's a good enough sketch for this. What we want to be able to identify is, here's the origin, and here's some xy. And what we're doing is we're finding this distance. And this is what we're calling d. And so here's 0, 0. And this is our point P, x, y. But we are given the equation y equals x squared minus 8 right here. And so what that tells us is that this point is also represented by x comma x squared minus 8. And so now I have my two ordered pairs. I can use the distance formula to express the distance between 0, 0 and x comma x squared minus 8. So for part A, I'm going to have d equals the square root, right? And so the distance formula is like x2 minus x1 squared plus y2 minus y1 squared. So that's going to be boiling down to x minus 0 squared plus x squared minus 8 minus 0 squared. And then let's just go ahead and clean this up. We'll have x squared, the 0 is gone, and we'll multiply this out, so I'll have x to the 4th minus 16 x squared plus 64. I can combine like terms, and I'll get d equals, and let's put x to the 4th in front. So d is going to equal the square root of x to the 4th minus 15 x squared plus 64. And so this is the function that represents the distance between the origin and any point on the curve. So for part B, what part B is asking, we don't even really need to use this function. We can verify it for sure, but what we're doing is we're wanting to know what's the distance between the origin and the point on the curve when x is 0. When x is 0, the y coordinate is negative 8, so we're wanting to know the distance between 0, 0 and 0, negative 8. That distance is going to be 8. So when we use the formula, if x is 0, if x equals 0, d will equal the square root of 64, because these two are gone, and the square root of 64 is 8. For part C, now we want to know what d is if x equals 1. So then you're going to replace 1 with the x's. So we'll have 1 to the 4th is 1 minus 15 plus 64. And then this is going to simplify to square root 50, or 25 times 2, or 5 root 2. Alright, and then the next part has us look at Desmos. So what we're going to do is, in Desmos, we're going to graph this function. Okay, so here's the graph of the function. We can see that it's an even function because there's symmetry across the y-axis. And we just wanted to look at when x was greater than or equal to 0. And so the next question is to look at for what value of x is d the smallest. And if you just get your cursor around the smallest point here, Desmos automatically finds it for us. And so the smallest point is the smallest x value for when the distance is smallest. Sorry, that's x value that of where the distance is the smallest is x equaling 2.739. So that last question is saying x equals erase because something's funky. So x equals 2.739. And so that's the value for x when d is the smallest. Alright, so in calculus, what you would do is you wouldn't just graph this function on Desmos. While it obviously is helpful, you can algebraically find this spot using calculus, and that's one of the things that you'll be learning, which is why it's important to be able to come up with this type of function on your own. Alright, I'm going to get ready for that next problem.